got some motherfucking design on right now. Bring it down, bring it down, bring it down. I got 3 old guys on the block.
Good day, everyone. I am Katrina Bauman, and today I will be discussing the fundamentals of mathematics, specifically sets, the real number system, and number theory. These topics may look simple, but they are actually the foundation of almost all math skills we use, from solving classroom problems to answering questions in the licensure examination for teachers or LET. As future teachers, we must not only know how to solve problems, but also explain them clearly to students. So by the end of this video, you should be able to use set notation correctly, perform operations on sets, apply PEMDAS accurately, solve integer problems, use divisibility tests and prime factorization. Now let's start with set. Now what is a set? A set is simply a group or collection of objects. That's it. Very simple, right? In real life, we group things all the time. For example, if I say, list all students wearing white shirts today, that group is already a set. If I say, all even numbers less than 10, that is also a set. So a set just means grouping similar items together. Now, how do we write a set? We use braces to list elements. For example, A is equal to 1, 2, and 3. This explains carefully. Inside the braces are the elements. So 1 is an element, 2 is an element, 3 is an element. There are 3 elements in total. So we write N A is equal to 3. The letter N means number of elements. So if a number is inside a set, we say it belongs to this symbol and A, meaning 2 is inside the set. If it is not inside 5, this symbol A, meaning 5 is not included. Think of it like attendance. If your name is on the list, you belong. If not, you don't belong. So these are the type of sets. Let's connect this to real life. Empty set. Months with 32 days. Let's check. January? No. February? No. All months? No. So the answer is nothing. So this is an empty set. Finite set. The days of the week, we can count Monday to Sunday. Only 7. So this is finite. Infinite set. Counting numbers. 1, 2, 3, 4, dot, 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 dot. Does it stop? No. So it is infinite. Now we have operations. Union. Union means combine everything without repeating. Example. A is equal to 1, 2, B is equal to 2, 3. Step 1. Write all the numbers. 1, 2, 3. Then remove duplicates. 1, 2, 3. So the answer is 1, 2, and 3. Intersection. Intersection means common only. Compare each number. Is 1 in both? No. Is 2 in both? Yes. Is 3 in both? No. So the answer is only 2. So let us pause and try. A is equal to 2, 4, 6, 8. B is equal to 4, 5, 6. Find the intersection. Done? Very good. The answer is common numbers are 4 and 6. So the answer is 4 and 6. Now let us move on to real numbers system. We have natural numbers. Natural numbers are the numbers we use for counting things. They start from 1 and go up. 1, 2, 3. Examples. Count the chairs in the classroom. There are 4 chairs in the classroom. 1, 2, 3, 4. Count the number of books on the table. 1, 2, 3. We do not include zero or negative numbers in natural numbers. So natural numbers is 1, 2, 3, 4. Now think of it. Anytime you answer how many, you are using natural numbers. Now let's move on to whole numbers. Whole numbers are natural numbers plus 0. 0 is included because it represents having nothing, but it's still counted. Examples, if no students are absent, there are 0 absences. Student present, 1, 2, 3. So whole numbers is equal to 0, 1, 2, 3, and so on. So think of it. 0 as a placeholder. For example, if you have 0 apples, you still understand the quantity exists. It's just none. Now let us move on to integers. Integers are whole numbers and they're negatives. They include positive numbers, 0, and negative numbers. Examples. Money. 100 is equal to savings. 50 is a debt. Or negative 50 is a debt. Now let's take another example of temperature examples. We have negative 2 Celsius is equal to cold morning. Positive 5 Celsius is equal to warm noon. Now let us move on to absolute value. Absolute value is the distance of a number from 0 ignoring the sign. For example, you are 5 steps away from the door, either left or right. Distance is equal to 5. So 5 equals 5. Negative 5 is equal to 5. Always positive. Think, distance can't be negative. Now let us move on to basic operations. Addition, subtraction, multiplication, and division. Addition is adding or combining quantities. Example, 3 apples plus 2 apples equals 5 apples. Subtraction, meaning subtracting is taking away. Example, 7 candies minus 4 candies. You remove 4 equals, there are 3 left. Multiplication. Multiplying is repeated addition or groups of numbers. Let's say 4 times 3 is equals to 4 groups of 3. 3 plus 3 plus 3 plus 3 plus 3 is equal to 12. Division. Dividing is sharing equally or splitting into groups. We have 12 divided by 3. 12 objects divided by into 3 groups. Each group gets, very good, 4. Now let's have order of operation or PEMDAS. PEMDAS is the correct order to solve math problems. Parenthesis, exponents, multiplication, division, addition, and subtraction. Example, 6 plus 12 divided by 3 times 2. Step 1, division. 12 divided by 3 is equal to 4. Step 2, multiplication. 4 times 2 is equal to 8. Step 3, addition. 6 plus 8 is equal to 14. So the final answer is 14. Now, let's pause and try. Solve 9 plus 6 times 2 minus 4. Okay, now let's try to solve. Step 1 is you have to multiply 6 times 2 is equal to 12. Step 2, addition. 9 plus 12 is equal to 21. Now for the last step is subtraction. 21 minus 4 is equal to 17. So the final answer is 17. So comment down below if you got the correct answer. Now let us move on to number theory. So we have divisibility test. Divisibility test tells us whether a number can be divided evenly by another number. Example, 246. Check divisible by 2. Last digit, 6, even divisible. Right? Check divisibility by 3. Add digits. 2 plus 4 plus 6 equals 12. Divisible by 3. 246 divisible by 2 and 3. Now let us try. Let us pause and try. Is 150 divisible by 5 and 10? Answer is yes. 150 is divisible by 5 and 10. Comment down below if you get the correct answer. Now, let's move on to prime numbers. A prime number is a number greater than 1 that has only 2 factors, 1 and itself. Example, 5. Factors of 1 and 5 only. So that is what we call prime number. 7. Factors of 7 is 1 and 7 only. So that is also a prime number. 6. Factors of 6 is 1, 2, 3, 6. Is that a prime number or not? Very good. That is not a prime number. Now, let us move on to composite number. Composite numbers are numbers greater than 1 that have more than 2 factors. Example, 6. Factors of 6 is 1, 2, 3, 4. Therefore, it is a composite. Another example, let's have 8. So the factors of 8 is 1, 2, 4, 8. So that is what we call composite. Now, let's move on to prime factorization. Prime factorization is breaking a number into a product of prime numbers. Example, 18. Divide, step 1. You have to divide by smallest prime. For example, 18 divided by 2 is equal to 9. Step 2, divide 9 by smallest prime. 9 divided by 3 is equal to 3. Step 3, divide 3 by smallest prime. So 3 divided by 3 is equal to 1. So prime factorization of 18 is 2 times 3 plus 2 times 3 times 3. So that is the final answer. Now, let's quickly review the main points we covered today. 1 is sets. A set is a collection of objects. Types of set, these are the empty set, finite set, and infinite set. Operations are the union, combined, intersection, common. Their difference is only in one set. The second one is we have the real number system. Includes natural numbers, whole numbers, integers, and absolute value. Operations are the addition, subtraction, multiplication, division. Always follow PEMDAS for the correct order of calculation. The third one is we have the number theory. Focus on divisibility, prime numbers, composite numbers, and prime factorization. Prime factorization helps break numbers into smaller prime components. Now, here are the key ideas to remember for the LET exam. Number 1. Understand the meaning first. Don't just memorize formulas. Number 2. Be confident with set operation and subset concepts. Number 3. Practice basic operations and order of operations with real numbers. 4 is you need to master prime numbers and factorization as they appear frequently in exam questions. So here are the additional resources for practice. That's it, guys. Thank you for watching this lesson. Remember, keep practicing these concepts and I'm sure you'll do great on the LET exam. Don't forget to review the key takeaways and the examples we did today. If you have any questions or need clarification, always ask and practice step by step. Keep learning, stay confident, and enjoy exploring the world of numbers.